Lindgren, we're learning about division properties of exponents.
Alright,
So good. So this is the last thing of this chapter. All right, we've learned about multiplication properties of exponents, zero products of properties, zero properties of exponents, scientific notation. There's only really 5 things in this chapter. Tomorrow we're going to review. Block day we're going to review. Friday we're taking a test. Okay, so some of you will do okay on that, but you got to know about division properties of exponents. So the first,
let me just interrupt a minute. All of them could do okay.
all of them could do okay
Yeah,
if you apply yourself
exactly.
a little bit. Whoops, that's, oh, I don't want this tool anymore. That tool messes me up.
58.
But I didn't want to write 58. I wanted to write it. You can't erase it?
No.
Oh my goodness, I can do.
Can't you undo it?
Edit. Undo. Cut. I can just cut it. What? I can undo it. I can undo it. That's what I wanted to do. Say you have 5 to the 8th power. 5 to the 8th power over 5 to the 3rd power. Does anyone know what that is equal to? Other than AJ? I know you know. I don't want you to give away the secret. Okay?
Yeah, it's like something over something.
Nah, it's easy. Look. This means 5 times 5 times 5. I'm going to write all these 5s up. How many 5s do I write?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. Right? This means how many 5s on the bottom?
3.
3. How many of those 5s cancel out? 3, right? 1, 2, 3 of those. And what I'm left with is 5 5s on the top, which I can write as 5 to the 5th. Okay? Now, what have I actually done with these exponents? Subtracted them, right? So that's the rule. All you really have to do is subtract when you're dividing with numbers that have the same base. You subtract the exponents, okay? So for any 2 numbers, the rule is for every non-zero number A, I'll write the rule. For every non-zero number, I should use my fixing tool now, number A, and integers, which an integer is a whole number which can be negative or positive. And integers m and n. A to the m over a to the n equals a to the m minus n. Okay? What that says, if the bases are the same, this is called the base. So this number here has to be the same. But if it's division, all you have to do is subtract the exponents. So let's boost it up a notch. Who's going to get a participation point?
We have a quick question.
What?
This has just been off topic, but can you have 0 to an exponent?
Yeah, that's an excellent question, Fred. 0 to an exponent, like 0 to the 5th?
Yeah.
Yeah. I mean 0 times 0 times 0, which doesn't really have much meaning. What you can't do, you can't have 0 to 0, like when you take calculus, that's called the undefined term. The undefined, it doesn't really have a meaning because you can't really raise something. That's why they define as something to the 0 as 1, because it doesn't really make sense, but it makes the math work. You see? Okay? So let's do this one. Who wants to do this one for me? 3 to the 7 over 3 to the 2. Who's got this answer? Sam's got this answer. What is it? 3 to the 5th. Very good, Sam. Sam gets a point. You're going to remember these. Sam gets a point. What if I have, okay, so now we're going to get a little bit trickier because I think, you know, like I like to throw curveballs at you. What if I have 2 to the third over 2 to the negative 7? What's that equal to? That's kind of weird. What do you think, Sophie? Sophie's using her fingers. Michael Minicello.
Would it be 2 to the 10?
2 to the positive 10th. That's weird, but it's true, okay? Because, and because it's 3 minus 7, right? So it's 3, so minus 7 is a plus, right? So that's equal to 2 to the 10th. So another way to think about this is I could have written, do you remember this rule? That if it's negative exponent, what could I do with it? To make it positive.
Put it on the bottom.
Put it on, if it's negative on the bottom, I could bring it to the top. And then I have 2 numbers that are on top. And then what do I do with the exponents? Add them, right? So this is so I could have, if I wanted to, rewrite this as 2 to the third times 2 to the positive 7, and then add the exponents. Okay? So very good. All right. So now, oh, don't you hate this? It gets harder and harder and harder. A to the 5th, A to, but how about this? What if I had A to the 5th over A to the 9th, and they say simplify. Who got that one? Who got it?
1 of A under 1 to the 4th power or something.
Wait, go, Sam's got his hand up. Go ahead.
1 over A to the 4th.
Perfect. How'd you get that?
Well, I subtracted 5 by 9 and that gave me a negative 4. And I
Good.
just put it downstairs.
And then you put it, so if I subtract 5 minus 9, I get negative 4. And then he put it downstairs and made it positive, okay? And that is exactly what you should do. This answer is kind of correct, but this answer is more correct over here, okay? And I would probably take a point off, like on a 5-point question. If you didn't simplify it like that, I would take a point off. All right, let's get serious here. What if I had c to the negative 1? So now they do stuff like this. They have c to the negative 1, d to the 3 over c to the 5th, c to the 5th, d to the negative 4. Who can simplify that for me? No negative exponents. No negative exponents. Who's got it? Other than Sam. Where's the right side of the room today? Come on. Oh, Michael has answered the question. Maria, you can do this one. What's this one? Maria. Do this one. Mary. Come on.
I don't really know if it's right.
Go ahead. Maria.
I don't know if you're supposed to like minus the c, so negative 1 minus 5 is negative 6.
Yeah?
But
See?
put a 1 on top.
Okay, let's wait to do that.
And then the d's 3 minus negative 4 is d to the I think it's to the negative. So
No.
it's 3 minus
3 minus
it's
minus
negative
4.
1. Oh, positive 1.
No. 3. What's a minus a minus?
Oh, a plus.
So it's 3 plus 4.
Seven.
7, right? And then you were on the right track with this c to the negative 6. What do I do with that?
You put 1 over it.
You put it over 1, or you could just bring it downstairs just like that. Okay? And that would be your nice simplified answer. Just like that. Okay? Let's do a few more. You try. Oh, this one looks hard. I'm not going to do that one. That one looks too hard. Let's give it to, what if I have m to the negative 1, n squared over m to the 3n. Who's got that one? Who's got that one? You can do it. Come on, Brittany. Come on. You've got it. AJ's got it.
It's 1 over n to the negative 4th.
1 over m to the negative 4th?
Yeah, it's negative 1 minus 3.
Yeah, but that stays up top, right? Sorry. Elise is going to try.
M to the second over, or n to the second over m to the fourth.
Minus n to the second? N to the, no. But what number is here if you don't see anything? 1, right? So it's so, yeah, so it's n to the first over what?
Over m to the fourth.
Over m to the 4th. That would be correct, I believe. Wouldn't it be? No? Yeah, it would be correct. So if you want to take a different route to get there, rather than just try to simplify everything at once, right? M to the negative 1 minus 3 makes m to the negative 4, right? And n to the 2 over n to the 1 makes n to the 1, or just plain old n. And then I bring the m to the 4th downstairs. So you don't even have to write a 1 there. If it's just plain old n, it's understood that the power is 1 over m to the 4th. Okay? It gets more complicated, I'm sorry. Whoa! What if I had something like this? 2m to the 3rd raised to the negative 4. Ooh. Baby. That's a hard one. Any ideas? That's not even really that's not really what I wanted to do, is it? That's okay. This is 2 to the what? What do I do with this? What's here that I don't see? A 1. So what's 1? What do I do with these? Add them or multiply? Multiply. So it's 2 to the negative 4th m to the negative 12, which can be read. I don't know why I threw this one. I should have looked at my notes. But 1 over 2 to the 4th m to the 12, which might be better as 2 times 2 times 2, which is 1 over 16, and 2 times 2 times 2 times 2, like that. That would be your best answer for that. That's not really what this homework is all about. I just thought I'd throw. Oh, here we go. This is the one I want to do. What if I had a 3/5? This is the one I want to do. What if I had 3 over 5 raised to the negative 2? Look. You guys know how to deal with that? There's an easy rule. 3 to the 5. This means if a fraction is raised to the negative 2, this means there's a couple of ways to think about this. It's 3 to the negative 2 over 5 to the negative 2. But if these are negative, what can I do with this one? Bring it where to make it positive?
It's 5 to the second over 2 to the second.
Right. Bring this one down to make it positive. Bring this one up to make it positive. So this is equal to 5 to the positive 2 over 3 to the positive 2, which is 25 ninths. Okay? Or an easier way to remember it is if you have a fraction raised to a negative power, you can flip it over and change it to a positive power. So if you have a over b raised to the negative n power, that's equal to b over a raised to the positive n power. That's another good rule to write down, to remember. Okay? You should be writing that down, this one right here. Okay? examples, 2 or 3. We still got time. This is why I didn't want to give you a warm-up today. What if I have, oh, here's the super, should we do the hard one? I think we should. 2 examples, and then I'll be done. -2, -2x over y raised to the -4. I'm just going to do this one, then I'll ask you guys to do it. Okay? So when this is negative, it means take every single thing in here and raise it to a negative power. So you have -2. Whoops. Sorry. My pencil messed up. So you have -2 raised to the -4th. You have x raised, and that's kind of like this. It's -2 raised to the -4th. X to the, that's a bad minus sign, isn't it? X to the -4th over y to the -4th. But I could have just flipped this at the beginning, right? But what happens to all these, how can I change all these negatives into positives? Flip everything upside down. So I could write this as -2, it's still -2, raised to the +4th, x to the +4th, over y to the +4th. And what I would go ahead and do, which you're supposed to do, is if it's a pretty small number, like -2 to the 4th, what's -2 times -2 times -2 times -2? Positive, very good. Emma said correctly, that's 16x to the 4th. And that's the way you do that, okay? Last one, you try, and then we'll start your own one, okay? You try. We're going to try 7a over m, 7a over m raised to the -2. You try. So who's going to get the correct answer to that one? And we'll be done. Wait, we have to hit pause. I'm going to unpause. I could flip this over, right? Using that last rule, I could just flip this over and make it positive, and then I have to square everything, okay? So I get m squared over 7 squared times a squared. What is 7 squared? 49. So I get m squared over 49a squared. And that's your final answer. All right? Your homework, should you decide to accept it, and you shall, is page 420. 1 through 55, every third problem. So what that means is 1, then what? Yeah, you skip every 2. So you go 1, 4, 7, 10, keep going, 13, until I think it ends at 55, but I'm not sure. Okay?